Hi, my name is Vineet, and today we're going to be taking a measurement with a USB data acquisition device. This particular device has 16 analog input channels, has 2 analog output channels, 24 digital I/O lines, and 2 counter timers. And it's actually connected over USB, and in fact gets its power over the bus. It's a bus-powered device, and so all I have to do is plug it into my computer here. And right away, the driver software can see that it's been connected, and I have a little window that comes up that says click here to use the device. At this point, I have a few different options. I can run some test panels or just configure the device, but in this case, I'm just going to start by beginning with an application using LabVIEW. I'm going to open up a LabVIEW blank VI. So VI stands for Virtual Instrument, and it's basically just a LabVIEW program. If you haven't seen LabVIEW before, it's a graphical development environment, and it's mostly made up of these 2 windows here. This first window is called the front panel, and I can right-click and drop down all sorts of user interface buttons like knobs and charts and graphs and buttons, anything that I'd like the user to be able to interact with in order to gain access to the code itself. I can put these windows side by side, and you'll notice that every time I drop down a user interface item, I actually have a corresponding terminal that gets populated on the block diagram. This block diagram here, this is actually where the graphical code resides. And so I can right-click and choose from a number of input functions, signal analysis, graphical programming structures like loops and cases, and Boolean controls, array manipulation, all sorts of different functions that any particular programming language would have. And in this kind of situation, all I'm going to do is I'm actually going to delete everything and start from scratch. And we'll see what it looks like to take a measurement. I'm going to right-click and go to the input palette and choose the DAC Assistant. The Data Acquisition Assistant is a configuration-based wizard that allows you to configure the different input and output channels for your data acquisition device. I can click on Acquire Signals because I want to take a voltage input. I can click on Analog Input. And in this case, you can see I have an option to choose voltage or temperature, all the different common sensor types like strain or pressure, vibration. In this case, I'm going to connect my data acquisition device to a function generator that's generating a sine wave. So I'm just going to choose a analog input voltage channel, and I'm going to choose AI0 for analog input 0. When I click Finish, I now have the option to configure my sampling rate and the number of samples that I'd like to take, so the number of measurements that I'd like to take to acquire a waveform. And in fact, let's go ahead and connect up the signal. I have a function generator here connected to a BNC cable. And so I can take this BNC cable and connect it directly to analog input 0 on my USB data acquisition device. And once that's connected, I can, right from the wizard, in fact, hit run and see my sine wave. And so this is the sine wave that I'm generating. I know that my signals have been connected correctly. And so because of that, I can finish configuring my sample rate and the number of samples and hit OK. At this point, the DAC Assistant is generating the code required to interface with the DAC device. And once the assistant is ready, I can right-click on the data output terminal and create a graph indicator. Once I do that, you can see I have a graph that's appeared on my front panel. I can make this graph a little bit bigger, and I can hit run. And right away, I have my sine wave. So every time I hit run, it takes a new set of samples. I can make this line a little bit thicker in order to see it a little bit clearly. And oftentimes, an acquisition task might not be a finite number of samples, but it might be continuous. So I want to continuously acquire samples until some user hits a stop button, let's say. So let's right-click let's double-click and open up the DAC Assistant. And actually, instead of a certain number of samples, I'm going to select continuous samples. From there, I'm going to hit OK. And then the DAC Assistant will notice that I've chosen to do continuous samples, and it'll ask if I'd like to drop down a loop. So in LabVIEW, in a graphical programming environment, we use loop structures in order to execute code continuously until some stop condition is met. And in this case, the stop condition is this stop button that's been created. I can move this to the middle here and make it a little bit bigger. And now when I hit run, I can see I can continuously take measurements, and you can see the sine wave moving. In fact, let me reach over to my function generator and speed up the sine wave. So you can see the faster samples being taken. I can slow it back down. And once I hit stop, I'm finished with my acquisition. So that's how to take a basic voltage measurement with an NI data acquisition device in LabVIEW.